Problem 2A. Alright, so review sheet 1, problem 2A. My given is the log of 2 and the log of 5. And the question is the log of 100. Now, in order to do the problem, this is all you have. So somehow 100 has to be broken down into 2's and 5's because that's all the information that I have. So can 100 be broken down into 2's and 5's? Yes. How can 100 be broken down into 2's and 5's? What's 100? 2 times 5. So 2 squared and 5 squared? Oh, it doesn't matter. That's okay. Yep. It's 2 squared and 5 squared or 10 squared, right? Everybody okay with that? Now, I need to break this apart so I have individually the log of 2 and the log of 5. So I can plug those numbers in. So if I need to break this apart, it's a multiplication. How will it be broken apart? As an addition. So it'll be the log of 2 squared plus the log of 5 squared. Right? Now, when you take the logarithm of something to a power, the exponents come out in front. That's one of the wonders of logarithms. So I can break that down to that, bringing those exponents out in front. And now look. Don't you have a number for this? So you're just going to take 2 times 0.12. And don't you have a number for this? So you're going to take 2 times 0.56. And then you're going to type that into your calculator and get the answer.
Before putting the 2 in front of the log, are you allowed to just put 0.12 into that and then square that?
No. Because it's not the logarithm squared, it's 2 times the logarithm. Yep. Nope, you gotta pull, it's the 2 that's being squared, not the logarithm. So you wanna pull that 2 out and multiply it by the logarithm. Okay? Now, let's go ahead and do B also. There's a part B to that same question. So we need to do the same thing. They didn't give me this. I don't have a number to put in for 25x squared. So I have to break down 25x squared. How will 25x squared break down? 5 squared, x squared. So I have the log of 5 squared x squared. Okay. Now they're being multiplied together, so I need to separate it. Remember, you need to separate it into these. You gotta have these. So I'm going to separate it into an addition, because again, it's a multiplication. So instead of multiplying 5 squared times x squared, I will add the log of 5 squared and the log of x squared. Now what? The 2's can come out, this 2 can come out in front. And what about this one? What's the log base x of x squared?
2.
Just 2. And I have a number for this, so 2 times 0.56 plus 2, whatever that is, would be the answer to that problem. We might as well do part C. It's the same thing, same given. Now the first thing that's like just popping out at you is that 4th root. We don't want that. So we'll rewrite the 4th root as 2x to the 1/4. And what's going to happen to that 1/4? It's going to come out in front. Now, did they give me a number for 2x? No. No. I need to separate it, right? How will I separate that? Once again, an addition, because it's a multiplication. Now, see that 1/4? It's out in front of both of those things. See that parentheses I put in there? That's important. That 1/4 has to be applied to both of these. Well, I have a number for this. And what's the log base x of x? 1. So, type that in on your calculator, and that's the answer to the question.
I don't know if you answered this already, but why can you cancel the, oh, just kidding. If you didn't cancel the log.
Okay. All right, Ms. Schomer, got that a little bit better now? All right, who else found something as you were doing all of your review work? Either a particular problem or a kind of problem that you feel like you need more practice on. Okay, wait, I'm looking at Sam, raise your hand. Which one, honey?
3F. I just want to make sure I'm doing it right.
Same worksheet?
Yes.
So this is review 1, 3F. If you have a doubt about whether you're doing it right, you can always check your answer with the answers on the back, right? Now this is actually the opposite of what we were just doing. What we were just doing is taking them apart. Now we need to put this together. We can't solve a logarithmic equation. This is an entirely different problem. It's a logarithmic equation, and we can't solve it with these two logarithms over here independent of each other. So we're going to put them together. We're going to write it as one logarithm. Now when we put them together, you're always going to put them together as either a times or a divide. Just like when you take them apart, you're always going to take them apart as a plus or a minus. So is this going together as a times or a divide? It's going together as a divide because it is a subtraction. So this is going to be x minus 2 over x plus 1. Now that we've put those together, we have log of left side equals log of right side. And if log of left equals log of right, then it makes sense that x minus 2 over x plus 1 equals 6, doesn't it? So x minus 2 equals 6x plus 6. Negative 5x equals 8. And x equals negative 8/5. Oh, no solution here. That's an extraneous root. And it's an extraneous root because if you put negative 8/5 back into the original problem, tell me about this number right here. It would be negative. Can you take the logarithm of a negative number? No, if you don't believe me, try it. Type ln something negative on your calculator and it's going to give you an error message. You can't take the logarithm of a negative number. Now I always add at this point that it isn't extraneous because that's negative. That doesn't have anything to do with it. That answer would be perfectly okay if this had been the problem. If this were the problem, negative 8/5 would be okay. Because what happens to this when you put in negative 8/5? Positive. Positive. So it's not the fact that's negative that's bad. It's when you plug it back in, this is negative. That's what's bad. Got it? Okay. All right. Take care of that, Samantha?
Yeah, thank you.
All right. What was your issue, Taylor?
Number 6. I get confused like when you're trying to figure out like continuous.
Did you notice I called you the right name?
No.
I did. I know. It never happened to you like that.
It's
Okay.
fine. My mom calls me Morgan too.
Okay. What do you mean you get confused about continuous? Continuous simply means you can draw it without lifting your pencil. So this is a continuous function. This is not a continuous function because there's two pieces to it. As long as there's only one piece to the graph.
Then it's continuous.
Yep.
Can we do number 6?
Number 6. for 5D, so we have to know what the picture for 5D looks like. So Peyton, do you know what 5D looks like?
It goes through the 0.10.
Yep, it's a logarithmic. Well, no, the original curve does. This one isn't. This one's been moved. But in order to do the problem, you have to know that the original logarithmic curve looks like this. This is the original logarithmic curve. Now, that's not a picture of my equation. That's the original. Now, what's going to happen when I graph this then? It's going to go left 1. So the asymptote is going to be over here at -1. The intercept's going to be at the origin, and it's going to look like that. So that's the picture that we're talking about. Of course, you're going to be confused if you don't know what this looks like. If you have not learned your logarithmic shape, you're in trouble. You need to know it. Then it's just a matter of shifting it 1 unit to the left. All right, what's its domain? Everything bigger than -1, not including -1, right? So if we're writing it like a mathematician, that would be the domain. If you said x is greater than -1, that is also the domain. What is the range? All real numbers. If you want to write that as a mathematician, it looks like that. If you want to say all real numbers, that's fine. Is that continuous? Yeah. I graphed it in one piece, no skipping, jumping, hopping, anything like that. Increasing or decreasing, we're going left to right. That's a constantly increasing function. Now, do we have functions that increase and decrease? Yeah, we're getting ready to study a biggie, the sine and cosine. But logarithms increase on their entire domain.
For which one?
And actually, so do exponentials, unless we reflected them and then they decrease on the whole thing.
So when you are talking about increasing or decreasing, you always go from left to right?
Left to right. Left to right. Does this thing have any symmetry? No. Is it bounded? Now remember, bounded refers to ceiling and floor. Is it bounded above? Nope. Bounded below? Nope. No bounds. Does it have any extrema? By extrema, we mean tops of hills, bottom of valleys. Nope, don't have any hills and valleys. Does it have any asymptotes? Yes, it has a vertical asymptote at x equals -1. End behavior. Now for this curve, end behavior can only be to positive infinity. There is no end behavior on this side because there's nothing on this side, right? So there's really only one end to talk about. And that end is doing what? As we go to the right, as x approaches infinity, what is this curve doing?
Increasing.
Going up. So its end behavior as x approaches infinity, so does y. Taylor?
On number 4 with the 3, like 4b with the 3 be like the index, and then you multiply it by
The denominator of a fractional exponent always is the index. Tells you which root to take. Always, always, always. The denominator of the fractional exponent tells you which root you are taking. X can't go to negative infinity. There's x, negative infinity is out here. This curve is not going this way. This curve stops at -1. It doesn't approach negative infinity. Now, it keeps going this way forever and ever and ever. But it doesn't go that way. It doesn't have an end on that side. All right, anything else?
in the packet, back of page 3.
The big packet? So in the big packet, I'll write the problem down, assuming I can find my big packet.
Number 2 and 4. You can use mine.
Yeah, let me just use yours, I'm not sure.
Wait,
Okay, which one, number 2?
Back and
Okay, so here's the problem, that's what's important. So I'll just write the problem down, so you can't find it. But it's in the big packet on the back of page, actually, it's on the back of page 4. Is that what you said? The back of page 4. So it's log base 6 of x plus log base 6 of 3 equals 2 log base 6 of 4 minus log base 6 of 5. This is another logarithmic equation, right? What's the issue? Too many logarithms. You can't have more than one on each side, so we're gonna have to do what? Put them together. So these two are gonna have to be put together into one logarithm. And, oh boy, these are gonna have to go together into one logarithm, but there's another problem over here, we'll deal with it in a minute. Let's take care of this first. These two can be put together right away. They're gonna be put together as the log of 3x, right? Now notice I'm not dropping the logarithms, I'm combining 2 into 1. I still have the log of 3x. Over here, I have an additional problem. What's my problem? That guy, he's gotta go, right? Now, a number out in front of a logarithm represents what? An exponent. So that is really a 16. What am I doing with the 16 and the 5? I'm dividing them. So this is 16 over 5. Right? Now what? 3x equals 16 fifths. So x equals 16 15ths. Valerie?
Can we use calculators on this?
No, not for this questions like this you can't. There is a calculator part. All the word problems have to be done with a calculator.
Okay. I put log of x plus 1 in my calculator, and then the graph like stops. Is that because the calculator can't go any further?
What do you mean it stops?
Like it stops at the point negative 0.95 because the asymptote was -1.
Right. And it's not showing you, it's going down. It may not be showing that, or it may be following the axis down. But if you expand your window, you'll see it going down.
Okay.
You won't have a calculator for the graphing problems either.
Okay.
All right, what else? Maria?
Do number 3 on the same packet.
The same page?
Yes.
Write a single, this is exactly the same thing, except it's not an equation. So we're just putting this all together into one logarithm. So you just want to have log one thing. Well, before we can start putting them together, what do we have to deal with? Same thing they had to deal with over here. Before you can put it together, you have to do what? Take care of the exponents. So this is going to be x to the 4th. This is going to be 8. And that just stays 7. Right? Now we're going to put it together. So these are being subtracted and that one's being added. So what am I going to have on top? 7x to the 4th. And what am I going to have on the bottom? 8. Because when logarithms are added, their numbers are multiplied. When logarithms are subtracted, their numbers are divided.
Can you do number 4? Why do you only,
We've already done some like this, Caitlin, but I will, but we've already done 3 exactly like this. So now the next one we're doing here is another one of these where you're given some information. And we're asked to find this. So this is the opposite of what we just did. What we just did was take all this and put it together into one. Now I have one, but I want to pull it apart. So how is that going to be pulled apart? what's gonna happen to the 3, the B, and the 2? The log of 3 plus the log of B minus the log of 2. Because when they're multiplied, you take them apart as an addition. When they're divided, you take them apart as a subtraction. And then we plug in our numbers. So the log of 3 is 0.2. What's the log base B of B? 1. And the log of 2 is 0.1. So you just add it all up and subtract it, and that's your answer. Okay, Caitlin, Mallory?
Why do you only multiply the 7 to the numerator in that equation? And not the 8? Why wouldn't it be 56 on the bottom?
It would be if I were dividing by both things. But I'm not. I'm only, turn that around. That can be written like this, can it? Can it be written like that? Clearly the 7 belongs on top. It's not being subtracted. The 7 is not being subtracted. It's being added. If I had parentheses here, then the whole thing would be subtracted and the 7 would be included in that subtraction. But it's not now.
Why isn't it seen as like 7 times x to the 4th over 8?
Because there's a negative out in front of it.
Okay.
If I were going to do 7 times 8, I would have to have, this says 7 times 8, and then I would subtract that. This says, if it confuses you in that order, write it in this order, and then you won't be confused. I'm not combining the 7 and the 8 here, right? Why would I combine them here? I don't. I don't know how else to explain it, except there's no negative in front of the 7, so it's not being divided.
Okay.
All right, what else?
I know I have to memorize the stuff on the back, but is this for the... Oh.
That's on Monday night, you're gonna memorize the stuff on the back. Yes, that starts us, those are things you have to know to do chapter 4. They have nothing to do with what we're doing now. Monday night, that's your job. And by the way, the purple one I gave you the other day, for chapter 4, there's stuff on the back of that one that you will memorize for the next chapter. Okay? But that waits until after you take the test to do that.
Can you do number 1 on that packet that we were just doing?
Oh my gosh.
Do you have questions?
At least you have questions. Not sure about these questions, but at least we have them. Okay. Number 1, this is still on the back of page 4. And it is another equation. So we've got 2 logarithms on one side, which we're not allowed to have. So the first thing we have to do is put these together. So how will those go together?
X plus 2 over 3.
They'll go together as a division. So x plus 2 over 3. Now what?
4 to the 2nd.
Got to get rid of that logarithm, so we translate it. 4 to the 2nd equals x plus 2 over 3. So 16 equals x plus 2 over 3. 48 equals x plus 2, so it looks like x equals 46. Now, you can't read my mind, so you don't know what I'm doing, but every time I solve a logarithmic equation, I look back at my problem and what am I checking? I'm checking to make sure that when I plug 46 in, everything stays positive. If this had been, for example, x minus 50, then 46 would be an extraneous root, right? So I'm just checking that. Every time I do one, I just take a quick look at it. Hey, is that going to be okay? And it is. 46 works. It's fine.
3D on the review sheet 1.
Review sheet 1, 3D. Says solve. Now that one is circled. That's a calculator problem. Gonna need a calculator to do this one. So who knows how to do this problem? this was on the, practice test thing yesterday, this kind of problem was. So how do I start? Gotta get rid of the base 6 logarithm. You cannot deal with a base 6 logarithm. If I had that button on my calculator, I'd press it, but I don't. So I gotta get rid of it. But now, my variable is an exponent. So what do I do when my variable is an exponent? I take the logarithm of both sides. And then that exponent comes off. And I end up with the log of 21 over the log of 6. It will always be the case when you evaluate that it's log 21 over log 6. That will always be the case. You're going to memorize that. It'll work every time.
So how do you know when to like keep the log on 21 and like 6 rather than like just put log and then in parentheses 21?
No. Anybody understanding what her question is? I'm not getting it.
On number F, like on letter F, we didn't put ln x minus 2 divided by ln x plus 1. We just put ln in front. But on this one we put log on the front of both of them.
But like, why did you say subtract? Why did you say log 21 minus log 6?
The property says log A over B equals log A minus log B. That's what the property says. There is no property for this. This is a different scenario. The logarithm of a quotient is different than the quotient of the logarithms. So if you're dividing logarithms, then you're dividing logarithms. There's nothing to do. If you're taking the logarithm of a quotient or the difference of the logarithms, but these are two separate things. I mean, they just are different scenarios. Danielle?
On review sheet 1, can you do 3D?
3D. I gladly will. It's identical to this one right here. It's exactly the same problem. ln x plus ln 5 equals 2. Issue is I got two logarithms that I can't have. So I'll put them together, so it'll be ln 5x. Now I've got one logarithm just like I had here. So what do I do?
It would be e
The base is e.
squared.
So it's e to the second equals 5x. And x equals e squared over 5. And if I don't have a calculator, that's how I leave that e squared over 5. If I have a calculator, I could type that in and get a decimal.
Can you do the bonus on page 5?
Okay, now this is on page 5 of the big packet. And this was the bonus question. If you watch the videos, I did 4 of these on the videos. This was actually a little easier than a couple of the ones on the videos. But the idea is this equation is in quadratic form. This is actually a quadratic form equation. If I let m, or some letter, be e to the x, this is 3m squared, 11m minus 4. This is confusing me, so I'm going to take it out and think of it as an m. So e to the x is m. Now, does that factor? Yep. Some of you aren't very good at factoring, so I'll work on it for a minute. But this factors like this. So go back and say, okay, well, I let m be e to the x, so what would the factors be? 3 e to the x minus 1 and e to the x plus 4. Did it say factor or solve?
Factor.
Oh, factor.
Factor, yeah. So there are the factors.
just have a question. Back on the one with the e squared, when you're putting that into the calculator to find it, do you put parentheses around the e squared?
You don't need to. If you do second ln, it'll pull up e,
Yeah,
and
but it
then
is,
you type 2, then you'll need to close the parentheses, because there'll be a parentheses around the 2, and then divide it by 5.
Well, I did it and I didn't put a parentheses around the 2, and then I put parentheses around the whole e squared, and I got a different answer.
Well, if you don't put parentheses around the 2, you're going to get the
Oh, the
wrong
whole
answer.
thing. Okay.
You don't need to put this in parentheses. It's not going to hurt to put it in parentheses, but that parentheses is going to come up automatically on the calculator. You have to close it before you hit divide by 5. Putting parentheses around the whole thing shouldn't change anything, but you have to have them around that too.
We did 3A because I got it incorrect.
3A, okay, it's exactly like these other two we just did. So let's see, we've got 2 logarithms that have to be put together. Can't have 2 on the same side, so we're gonna put these together. How do these go together?
5x over 2.
5x minus 10.
Wait, I did 5x minus over 2.
I don't know why you would do that. These are being multiplied. So that would be 5x minus 10. So we have 4 squared equals 5x minus 10. So 16 equals 5x minus 10. 26 equals 5x. I got 26 fifths. Let's take a quick glance up here, make sure that's all good. It is. So that's my answer. Okay.
Can you do number 4 on the supplemental word problems?
Supplemental word problems, number 4. That's in the packet, page 8. Number 4 says we have 2.5% compounded continuously. And, oh, then we want compounded, what rate compounded quarterly to be competitive. Okay. Okay, so I know that I can get 2.5% compounded continuously at a bank. And I want to know, okay, this other bank is only going to compound interest quarterly, so what rate would be needed to match the first one? I hope it makes sense to you that the more often you compound, the less your interest rate has to be. So compounding continuously is the max compounding. So this rate's going to have to be a little higher. You're only compounding 4 times a year. You're going to have to be a little higher to match the continuous. Well, how much higher? Well, I don't know. How much? Let's just pick a number to start with. Let's start with $100. Okay? If I am compounding continuously, that's per continuous growth. That's per. So how much will I have if I start with $100 at 2.5% for 1 year? Let's just do it for 1 year. What's that equal? Well, how much money would I have? I don't know. Do I need logarithms to figure that out? Nope, I just type it in. So I would have $102.53. Okay, now what interest rate would be necessary if I were going to compound quarterly? So everything is staying the same. I have to end up with exactly the same amount of money, starting with the same amount of money, but now I am compounding quarterly. So everything stays the same, $100 to start with, but I need to match my outcome that I got here. Am I going to need logarithms to solve that? Nope. What am I going to do first? divide by 100, so 1.0253 equals 1 plus r over 4 to the 4th. All right, what do I do now? Fourth root, yeah, it's like square rooting both sides, only you're not square rooting both sides, you are fourth rooting both sides, which is the same, if you prefer, as raising to the 1/4 power. So I'll take that 1.0253 and raise it to the 1/4 power. And then remember, you're solving for r. So once you get that typed in, you have to subtract 1 and times by 4. It's really close. That interest rate is 0.02506. So in order to match that, you'd have to offer 0.02506, which is about the same percentage. But all right, anything else we have to look at?
Same packet number 6.
Same page?
Yeah.
Number 6. Growth constant Precal A, so we got some kind of creature, and its growth constant is 0.1111. There are now 1 million, so I have 1 million of them. How many were there 8 hours ago? Okay, there's no formula given. So I need to figure out which one I'm using. What formula am I going to use for this bacteria problem? PERT? It's the only option you have, kids, if it's not money. So what goes where? 1 million is what I have right now. What's P? That's what I don't know. Interest rate 0.1111 times 8. Am I going to need logarithms to solve this? No. Actually, all I need to do is take 1 million and divide it by this. So 1 million divided by second ln 0.8888. So it looks like I started with 411,149 of them, approximately. All right, time for a couple more.
7B on review sheet 1.
Review sheet 1. 7. Oh, whoa. 7B is a property 5.
Oh, sorry.
No work. That's just a gimme. That's a gimme. 7D. G. Now it's a pretty much a gimme too, but it is a little more effort. We've got a radical. We don't want a radical in there, so we'll rewrite that as 1 over e to the 7/2. Why is it 7/2? Because the square root is 1/2, and we already had 7, so it's 7/2. Now what about 1 over? That means my exponent was negative. You have an ln and an e back to back. They always cancel, so your answer is negative 7/2. Okay, I would not wait until Sunday night to look at this again. I know we don't have class tomorrow, but waiting until Sunday night would not be a good idea.